So what's the formula for this compound? Okay. So the first thing you're going to do is use the same system I taught you for calculating molar mass. Before we go too far, when you plug this number in and multiply it by 5, what do you get on your calculator?
I got.
Well, what, did you get the same number?
Yeah, I got that. No? Why you put the 0 in there?
That's a good question. That's what I want to point out to you.
I didn't do that.
How many significant digits do I have here?
You got 4.
Okay? So that 4 right there on the end, that's significant. So that 0 over here is going to be significant. Yep. Yeah.
I thought you couldn't do that.
Well, let's add them. Remember, multiplication is just addition, right? Okay. So we're going to take 15.9994 and add it together 5 times. All right. So look, is there an empty slot in this column? Where's an empty slot in this column? There's no empty slot in this column. So there has to be a significant digit right here. That's where I get it from. Hmm?
It's fucking right there.
I'm not sure I understand what you're saying, Mike, Fred. All right, so this, and you have the practice test, right? Okay. So this 0 here is significant, and we don't round off that 4. Okay? And that's grams of N2O5, and that's equal to 1 mole of N2O5. Okay? This number here, then, when we're calculating molar mass, you don't do anything else with this. But when we're doing percent yield, what you need to know is this. This is the total mass of all the nitrogens in this formula. So this can be grams of nitrogen in this formula. This number is the total mass of the oxygens in this formula. So this is the mass of oxygen in this formula. To calculate the percent composition, you have to find the percent of both of those elements. You find the percent of all the elements in the formula. And the easiest way to do that is using molar mass. So we've got 28.0134 grams of nitrogen divided by 108.0104 grams of dinitrogen pentaoxide. Okay? Times 100, yeah. Percentage is always times 100, yes. So you have to do it for both elements. 28.0134 grams of nitrogen over 108.0104 grams dinitrogen pentoxide. And that's times 100. And that'll give us the first one we need. The second one is the mass of the other element here. If there were 3 elements, you do it 3 times. If there were 4 elements, you do it 4 times. All right, now I want you to pay attention to this, please, before we go any further. I want you to notice what I'm going to show you and explain to you. We're doing a percentage here, and I told you earlier that percentages, and when you calculate percentages, the units cancel. Sometimes the species cancels, but in this case, you can't cancel nitrogen with N2O5. Those are 2 different things. The units cancel, but the species don't here. Okay? All right, we want to round both of these off. How many digits do I want in the final answer? 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is 25.9358% nitrogen in N2O5, and this is 74.0642% oxygen in N2O5. Okay? Now, if we've done the math right, if you add the percentages together, what should you get?
100.
Really close to 100%. There you go. And that's how you can check to make sure everything's done right, or it's at least one kind of check. It may not be perfect as far as you might have set something up wrong, but you should get 100% when you add all the percents together. Does everybody understand? Anybody have any questions about this?
No.
Hey, Ralph.